Hello and welcome. My name is Robert and I'm going to be presenting your maths lesson today. It's great to be here. It's great to be able to do this. It's great to be able to bring the learning to you. And yeah, in today's lesson we're going to be speaking about analytical geometry. We're going to be moving a little bit forward. In the previous lessons we've spoken about distance and we've spoken about midpoint, and today we're going to be talking about gradients and we're going to be talking about lines. So let's jump straight into it. I've shown the content map again. It's fairly similar to what we've seen before. We can see here, oh sorry, let me just choose my pen. We can see here that I've included lines, and that's what we're going to be talking about today, which is more that was on the content map, but we're going to be starting with the gradient. Now, we've spoken about the gradient when we've done functions, we've drawn straight lines, we've done parabolas, and we've spoken about average gradients. But I just want to go back there. I want to make sure that we've got those concepts, because that's going to be critical in analytical geometry. So, what is gradient? The gradient of a line is determined by the ratio of the vertical change to the horizontal change. Now, that sounds super fancy and it's quite complicated, but all that gradient is it's a fancy word for the steepness of a line. How steep is a line? How flat is a line? And so if we look at this next slide and the image on it, we can see here I've got 4 lines. I've got OT, OS, OR, and OQ. And here we can clearly see that OT is the steepest line and OQ is the least steep line. All right. But when we're talking about gradients, and this is the thing here, is if I were to draw in, and let me do this in blue, if I were to draw in 5 more lines, suddenly I'm going to start running out of English words to describe what the steepness is. Like, this is the most steepest, and this is a little bit less steep, and this is the least steepest. And to actually describe each of these 9 lines with English words, it's going to be difficult and it's not going to be exact, and I'm not going to be able to apply it to the next image where I've got a line that is steeper than the most steepest line. And so what we're going to be doing is we're going to be, instead of assigning words to the steepness of a line, we're going to be assigning values. We're going to give a number to how steep a line is. Now, this number we're going to do by using this formula, all right? Exactly like we had formula for the distance and a formula for the midpoint, we've got a formula for the gradient. And again, please make sure that when you use this formula, you take it from the formula sheet. It's so easy to make a careless mistake and add instead of subtract if I try to remember that formula. So get the formula from the formula sheet, and let's make sure that we get these questions right. All right, so the formula for the steepness of a graph, the gradient of a graph that'll give the number, which is the steepness of the graph, is this. If I've got 2 points, O and S, so if I were working out the steepness of this line, what I would do is I would take the y value of the second point and subtract the y value of the first point, and then I would take all of that and I would divide by the x value of the second point minus the x value of the first point, and that will give me a number that would describe the steepness of a graph. Yeah, awesome. So let's jump into some examples. Here we can see they ask us to calculate the gradient between A and between B. And again, what is the gradient? They're just actually asking us, what is the steepness of this line? What we're going to be doing is we're going to be using the formula. So here I've got the same line and the same points. I've just put the sketch in the corner here so that I've got a little bit more space to work. And the gradient, which also, just as an insert, we generally going to refer to as M. I don't know why, but M it is. And M is going to be the gradient. And what am I going to do? I'm going to take the y value of the second point, and I'm going to subtract the y value of the first point. And again, we discussed this when we were doing distance in the first lesson, but it's so crucial that when I subtract a negative, that I put that in brackets. It's too easy to, by mistake, do 7 minus 3. It's not 7 minus 3. It's 7 minus negative 3, and that's important because that becomes a positive. That becomes 7 plus 3 and not 7 minus 3. And so let's be careful that we get that right. What am I going to divide it by? I'm going to divide it by the x value of the second point, and I'm going to subtract the x value of the first point. Again, I'm going to put it in brackets there. And let's go to our calculator. Let's do it on our calculator. I'm going to go 7 minus 3, and at the bottom I'm going to go 4 minus 1, and what we get is 2. And so this gradient has got a gradient of 2. Now if we go back to the previous sketch, and I just want to quickly talk about this, is here we had 4 lines, each with different steepnesses, and this line had a steepness of 2. If we go to a line that is steeper than it, it's going to have a gradient that is more, so 2.5 or 3 or 4. If we go to a line that is less steep, it's going to have a gradient that is smaller. So that's going to be 1.5, and this could be a gradient of 1. And so steeper lines will have bigger values, flatter lines will have smaller values, and all those lines that are going up will have positive values, and all those lines going down, you can see these are going in a direction that is downwards, will have negative values. And so this gradient could be equal to -2, and this gradient could be equal to -3. Now, if we go back to the next example, so the next example, exactly like we did with distance and with the midpoint, we started with values, and then we moved into an algebraic space. And that's what we're doing here, is we're going to be working out the gradient of algebraic points. And so here they ask us to calculate the gradient between C and D. Nothing changes here. I'm going to do exactly what we did. It looks a little bit strange because there's x and y's, but it's not. It's exactly what we've done, and we're going to use exactly the same formula. So the formula was m for the gradient is going to be equal to the y value of the second one, which is y plus 4, and I'm going to subtract the y value of the first one, which is y. I'm going to divide that by the x value, and let me do this in red so that we can see what's happening here. I'm going to take the x value of the second point, and I'm going to subtract the x value of the first point. But again, and what's crucial here is that when I subtract two things, when I subtract a multi kind of piece or something, I always have to do that in brackets, because I'm not only subtracting the x, I'm also subtracting the -3, and so I have to put that in brackets. Now, all that remains for me to do is I'm just going to simplify this a little bit, and so I'm going to get y plus 4 minus y, and here I'm going to see the y's will cancel out, and I'm just going to be left with 4 at the top, and at the bottom I'm going to have x. And what did we decide earlier is that in front of this bracket is a -1. And so I'm going to go -1 times by x is -x, and -1 times by 3 is +3. The x's will cancel out, and the gradient, what's left at the top is a 4, and what's left at the bottom is a 3. And so my gradient of these 2 points is 4/3, and it doesn't matter that it's not a nice number. That's perfect. Great. So here we're going to go to an ad break. I will see you guys soon.